Good morning. Today we will use how to use WEKA for nav bias, support vector machine, and nearest neighbor classifier. Okay, so we will do for the nav bias first. We will click the workbench. Okay, here you will see preprocessor, classifier, cluster, and so on. Now we open the file and we click the data and we choose the breast cancer. So in this video, I will use the breast cancer file. So I click the breast cancer file and open, and here it is. Okay, the current relation, it shows instances 286, which is 286 sample. These are attributes. One is for age, 2 menopause, and so on. And here is a selected attribute. And this is the class or class norm. We can visualize all of this. Yes, this is the graph for the attributes. Now we move to classify it. We click choose, and here WEKA have a many classifier, include bias, function, lazy, meta, misc, rules, and many more. So we click the bias and click the nav bias. After that, we click start. Here it is. This is kind of the summary for the nav bias. What we have to do is we see this correctly classified instances and incorrectly classified instances. So for the correctly classified instances, it shows that 205 is correctly classified 205 out of instances, which is 286. And for the incorrectly classified instances is 81 out of 286, which is represent 28.3217%. So this is all of this is a brief of summary for the data by using the nav bias. So time taken to build the model is 0 seconds. Now we move to how to classify the data by using the support vector machine. Okay, we click the classify and click choose and try to find it, which is it is located at SMO. Yes, it is SMO. For information, the WEKA, the classifier will is not the real name for the classifier, such as nav bias and support vector machine, not in the real name. So we have to find it by click one by one and see what is it. So we proceed to the SMO, which is the support vector machine, and the cross validation false is then same with the others, and click start. Okay, here is the summary for the data in the support vector machine, and the test mode is then false cross validation as this, and the kernel used is KMK1143. So this is the machine linear showing attribute weights, not support vectors. And the time taken to build the model is 0.13 seconds, which is different from the nav bias and k-neighbors. Okay, so for the summary is the correctly classified instances is 199 out of 286 instances, which is leads to 69%, which is it is lower than the correctly classified instances is lower for the support vector machine is lower than the net bias and k neighbors. So for the incorrectly classified instances is 87 out of 286 instances, which is lead to the 30%, which is more than net bias and k neighbors. So the detail accuracy by the class, confusion matrix, and all of this is the summary. Okay, that's it. Okay, we will use this data and classify it into the k nearest neighbor. Now we click choose and we try to find it. Maybe at lazy. Yes, it is IBK. We click IBK here and click start. Okay, how to see the data is just like the knife bias. We see the correctly instances, which is 207 correctly classified instances out of 286 instances, which is 72%. And for the incorrectly classified instances is 79 out of 286 and represent to 27%. The others is the summary for the data by using the IBK, which is k nearest neighbor. The time taken, the time taken to build the model is 0, same. And yes, that is. For this WEKA, what I can look good for this apps is software is for this three various we can see the correctly classified instances, each of it, which one is more accurate and which one is not. Okay, from my view, the most accurate correctly classified instances is k nearest bias, which is it is 72%, while the bias is 71, and the last thing is the support vector machine, which is 69. And for the incorrectly classified instances, the highest is the support vector machine, which is 30% more than the net bias and k nearest bias. After we classify all this data in net bias, in support vector machine, and k nearest bias, now you also can visualize it. Click visualize, and yes, you can see all it just the dots, but we can change it by change the plot size and plot size and point size. Okay, and click update. Now you can see it clear, right? For this one, it is just like a graph. Okay, let me show you. I will just pick this one. Okay, yes, it is a graph. This is the tumor size, and it is the what it classified for. You can see for the others too, like this, and so on. That's all. Thank you.